Hello and welcome to the 14th episode in this video series on Python natural language processing. In this video we're going to take another look at regular expressions. There's a lot to cover on this topic, however we're going to dive a little deeper into some practical tools that we can use right away to search for terms in our strings. And we'll end on a very classic example when you're learning regular expressions, which is to look at emails and look at phone numbers. So let's go ahead and jump right into it. The first thing we're going to do is we're going to import re. So that's importing the regular expression module in Python. And let's create our sample string. So let's have a phone number here. So that's one phone number separated by a dash, and then we'll have another number separated by dots, and we'll see why that's an important distinction in a moment. And we'll take a look at some email addresses. So we'll call worker-b@gmail.com, and we'll go with Ted, Mike, Ted at mail.com. Alright. So now that we have the string picked out, we'll see why, for example, it's important to know the dash versus the dot, and how some characters in our strings, for example the @ sign, can throw us off when we're trying to pick out words as a part of an email, for example. Alright, right off the bat, let's make an important distinction when starting out with re. You'll notice that search is pretty popular. That's a method in re, and what it does is returns the first instance of a value that you specify within that string. So let's look for Ted, and we need to specify that where we're searching. So I have here a literal string, which is Ted, and the little r that prefixes it, saying we want to look at a raw string. So this is a pretty strange format. It's probably not what you expected, or at least it wasn't what I expected when I first started getting familiar with regular expressions. But what search does is returns this object, and it tells us where it's located in this string. So it starts at 47 and ends at 50, but it's a match, so you know where it was located. And if you wanted just to return what you found, you could use the group method as well, and you will just get Ted. In this video we're going to focus on #findall, which is a nice solution to if we want to find multiple instances of a value. It just returns, now we don't get the positional information, but we do get that Ted occurs twice, and that's in this email here, and that's why I included that in that email name. Okay, so that's one important thing to know is, are we looking for one thing or multiple things? And I think it's a little more practical to use #findall, so we'll focus on that. And we'll briefly take a look at something we looked at in the last video, which was \w+. So what are we getting here? And what are we saying by using #findall in this w+? What we're asking for is word characters. So word characters are letters, upper and lowercase numbers, and the underscore. So that's what this special character /W specifies. So that's why we get 555, but we don't get a dash, and we get each occurrence where we're getting numbers and letters. And we're separated by the starting of that criteria of what \W is to a case where it doesn't match, and that's what separates these list values. So let's create let's say we don't want the numbers and we only want the letters, for example. So how could we do this? One thing we'll introduce here is the brackets. What the brackets are is we're specifying a set of information we're looking for. And they have some special characters within it too. Some meta characters. So one that's really common is the range. So the range is the dash. So what we're saying here is we want to return word characters, or I'm sorry, we want to return string items that are only letters, and so it won't be, and if there's a space, for example, wouldn't be included. We're only going to pick out lowercase letters, in this case, even because the capitalization matters, and that's a important distinction. So let's see what this returns. So what are we getting here? We're getting worker, we're getting B, we're getting Gmail, we're getting com, and so on. And notice we didn't get Ted, and we didn't get any names. So if we go here and go capital A to Z, we're only getting capital letters. So we get TMT because those are the only ones that occur. Now what's interesting about W plus is just a shorthand for uppercase, lowercase numbers, and underscore. So just really quick, I'll just demonstrate that you can also specify a range of numbers 0 to 9, and we get all these numbers in the phone from the phone numbers. So first we'll look at the phone numbers, and then we'll take a look at the email and look how we could learn to pick these out. So first, let's say that we're just starting out and we assume that the phone numbers are separated by dashes. So we go re.findall, and we're going to specify, and I'll show you another wildcard, or I'm sorry, another meta character they're called, is \D, which stands for digit. So a phone number typically has 3 numbers separated by a dash, separated by another 3 numbers, and ending with 4 digits. And I have to specify the string. Okay, and I alluded to it before, but here notice that even though we have the format for phone numbers, this dash here is interpreted literally. So one of the tricky parts about regular expressions when we're first getting started is knowing where are we using the special characters and when are we using the literal characters. So we can use a combination of both to create patterns. So if I change this 2 dots because perhaps that's the format that's of a particular website. And this is going to be a interesting case now that I think about it. So I'm going to return it. So why did I get both numbers? Well, that's because the dot character is actually a wildcard, meaning it can be anything. It can be a space. It can be any character on your keyboard. It's just saying that I don't care what the character is. It can be anything, and I'll allow it. So if I recall, the way to it's called escaping the wildcard. So I want to look for just a dot, is to use backslash in front of it. And then this way, we only get the dot. So that's a good practical example that we want to test out irregular expressions, and it's always good to create your boundary cases and work them out before you stick them in your program, especially if it's a larger one when you're debugging. Play around with them and see what you get, because that's one way to avoid errors, forgetting that there's wildcard characters, or working out the syntax of the regular expression. So what would be, so we did the escape, it's called here. So we're not really using the dot from what it's for. Another way to do that would be to contain the dot in a bracket. And we're back, folks. I just realized why this returned nothing. Now notice we need the backslash for each digit, and I accidentally deleted a digit when I used the brackets here. So here, when I rectified that, and this where I returned none because I really wanted the phone number, I simply just added the backslash into it and I returned the phone number. Because what this was looking for is I need a sequence where there's a dot, the letter D, and then 3 digits, which doesn't match any string in that one. So to elaborate a little bit on the brackets, so let's say that we wanted to make sure there was no hashtag in between numbers or something like that. We could use these brackets, and I could put a dash here and a dash here, and we just created a way to specify a set of characters that takes up a single entry in that string. Okie dokie. So now let's shift our focus to the emails. Now we can maybe assume here, and we'll just print string out one more time. So here's what we got. So what is common across all emails? Well, it usually ends in .com. So I'll go re.findall, and I'll go r, and then go like, for example, first pass guess might be our W plus, meaning we want to identify all the word characters up to the point where we don't have another word character. That's what the plus does. It extends from left to right. And we're going to look at the string. Oh, I'm sorry. So we're going to look for a word character that is a group of word characters that's to the left of .com. and I need to specify string. Okay. So why did we only get gmail.com and mail.com? Well, the @ symbol is not a word character from the criteria of the \W. So maybe if you wanted to find, if you had a mailing list and you wanted to know the most popular email domains, that could be useful. However, we want to know the full email address. So how could we do that? Well, we're trying to match the pattern of the email address. So after the domain and .com, what precedes that is the @ symbol. And let's do another +/W. So we're looking for a, oh, I'm sorry, not the plus in the beginning, a plus after. So what are we going to get here? Now notice in the case of Ted Mike Ted, that's perfectly fine. These are all word characters, there's no spaces, there's no dashes, so we're good to go. But in worker-B, you only get b@gmail.com. So if we were picking through email addresses and trying to contact that person, we would send it to the wrong person. Now how can we combine some of what we saw previously to get the full email address? Well, what we can say here is we can use a set, and in the set we could specify a dash, right? Because what we're saying here is any word, character, and dashes. And when we return that, we get worker B. And even more, and this is actually pretty useful because if you want to make sure you exclude certain characters, or if you know certain characters aren't contained with it, you can make your custom set. I mean, you could always put a or we'll leave it at that. You could just put the dash, or if you have other kind of email addresses, for example, the I think the underscore is covered, but you could put $, and a bunch of other criteria. And they got an error, so let's see what was wrong with this one. Okay, so we want to be a little careful. So this is actually good that this error happened. So notice it says bad character range. So it's reading word character to $, and it's not understanding what that means. So I can't put a dash. We want to put the dash at the end. Let's see if that works. Okay, and that works. So be a little careful. That is the trick and of using regular expressions is work through your examples and do your best to come up with some boundary cases. Things like that when we're rushing around in our programs can throw us off. Don't get frustrated. There's some good resources online if you're getting syntax errors like that. But it's a good tool set to have, and it allows us to sift through strings and, for example, pick out emails and phone numbers like we saw before. And notice how we could generically select phone numbers. For example, if there are dashes or periods that separate the numbers. And if you were to kind of look through a number of websites, you'll see them all in different formats. And that's the power of the regular expression, is we can build that logic into our searches. So thank you for watching this video, and I've hope that you've learned more about regular expressions. And they are a little tricky. Your expressions can get pretty long, and if you Google them, you'll see people with really long criteria. However, start simple and then build from there, and in no time you'll be up and running and searching like a pro. So thanks for watching this video. I hope you learn more about regular expressions, and stay tuned for more content.